Hello children, welcome back. Now I am dealing with 10th class real numbers first chapter. Now before going to that chapter, let us talk about a small problem. Bad cause means many words. What do you mean by this? Bad cause. Bad cause in the sense any wrong that you have done. Usually we come across with many people who always do mistakes but they don't accept. They always want to defend themselves. They say that no, I have done rightly. I did this because I thought like this, or I'm doing, I expected this. Like that, so many explanations they give. Whatever they do, they cannot convince anybody. The reason is, that is not the correct thing. So children, when you are doing wrong, don't try to defend it, because how many words, how many sentences, whatever the best language you use, you cannot make a wrong right. So accept the mistake, say sorry, and try to not to do that mistake once again. Come back to the topic, children. Now I am doing with logarithms, and in this logarithms we are going to talk about properties. This is 10th class real numbers. In real numbers, we are going to talk about properties of real numbers. So, the first property is called product rule. Product rule. So what does this product rule says, children? It is a theorem you have got. In product rule, a theorem is given to you. Let A, X and Y be positive real numbers where A is not equal to 1, then log xy to the base A is equal to log x to the base A plus log y to the base A. This is the property called product rule, children. X into y, you are multiplying two values. When you are multiplying any two values under logarithm, that is nothing but addition of those two values. Now let us see a proof of it. How will you prove it? Let us go for LHS. What is LHS, children? Let log xy to the base A is equal to p. Some value p we are considering. This is logarithmic form. If you convert it into exponential form, a to the power of p is equal to xy. When you are converting logarithmic form to exponential form, already we have done it in the previous class. Now go to the RHS. In RHS, you have got log x and log y. So let log x to the base A is equal to p. Yeah, already p you have taken now. So we will take q. P you have already taken, you take it as q. What does this implies? A to the power of q is equal to x. Now you have log y to the base A is equal to r. What does this implies? A to the power of r is equal to y. So each logarithmic form we have converted into exponential form. Now when you are talking about x into y, means x into y. X into y is a to the power of q into a to the power of r. We know that when bases are same and multiplied, powers should be added. So a to the power of q plus r. So xy is equal to a to the power of q plus r you got in RHS. In LHS, xy is equal to a to the power of p. So we will say that a to the power of p is equal to a to the power of q plus r. Are you following, children? See, we have got a to the power of p is equal to x into y. X into y you have got it as another x into y, a to the power of q plus r. When these are equal, the other ones are also equal. So a to the power of p is a to the power of q plus r. When bases are same and equal, powers should be equal. P is equal to q plus r. What is p, children? Here, see, p means what? Therefore, p means log xy to the base a is equal to what is q? Log x to the base a plus log y to the base a. This is the proof of the theorem that is given to you, children. Product rule theorem. What does the product rule theorem says? If a, x, y be positive real numbers, where a is not equal to 1, you should not get this as 1, then log xy to the base a is equal to log x to the base a and log y to the base a. So LHS we have taken, log xy to the base a we have taken it as p. This is logarithmic form. I have converted logarithmic form into exponential form. A to the power of p is equal to xy. Now when you go to the RHS, log x to the base a is equal to q. So a to the power of q is equal to x. Logarithmic form is converted into exponential form. Then log y to the base a is equal to r. That means a to the power of r is equal to y. So when you are multiplying this x into this y, a to the power of q into a to the power of r. When bases are same and multiplied, power should be added. So a to the power of q into a to the power of r can be written as a to the power of q plus r. And already we know that xy is equal to a to the power of p. Here xy is equal to a to the power of q plus r. That means what? These two are also equal. A to the power of p is a to the power of q plus r. When bases are same and they are equal, powers are also equal. So p is equal to q plus r. P means what you have taken? Log xy to the base a. Q means log x to the base a plus r means log y to the base a. So this is the proof, children. Copy it. Next. Okay. Basing on this product rule, you are having some do this problems, children. You have do this problems in page, I think 22. So do these problems in page 22. Let us see what are these do these problems. Express the logarithmic form as sum of express as sum of logarithms. Sum of logarithms. This is the question, children. So first bit, what is given to you? 35 into 46. Let us take this as log 35 into 46. Actually, when numbers are there, you have to write it as base 10. If you have letters, variables, we will write a. If you have numbers, we will write base 10. So this is nothing but log 35 to the base 10 plus log 46 to the base 10. What is the reason, children, here? Because log xy to the base a is equal to log x to the base a plus log y to the base a. This formula we have utilized here. Now the second one, 235 into 437. So log 235 into 437 to the base 10 can be written as log 235 to the base 10 plus log 437 to the base 10. The reason is same. The same reason, you can write it here. Then third bit, 2437 into 3568 log 2437 to the base 10. These are all we can write this as log to the base 10 is equal to log 2437 to the base 10 plus log 3568 to the base 10. The reason is the same above. So these are the 3 problems given to you, children. So I hope you have understood. Copy this. Now, in the same page, you have another theorem. That theorem is called quotient rule. Quotient rule. First one what you have done is product rule. Now it is quotient rule. This quotient rule, you have got a theorem. Now what is the theorem? Again here, let a, x and y be positive real numbers where a is not equal to 1, then log x by y to the base a is equal to log x to the base a minus log y to the base a. When you are multiplying, you will add it. When you are dividing, you have to subtract it. Let us see the proof for it. The proof here is, take LHS, let log x by y to the base a is equal to p. What does this imply? A to the power of p is equal to x by y. Now go to RHS. Let log x to the base a is equal to q. This implies a to the power of q is equal to x, and let log y to the base a is equal to r. This implies a to the power of r is equal to y. Now, what you need to find out, children? X by y. So, what is x by y? X is a to the power of q by y is a to the power of r. Now, that means x by y is equal to, when bases are same and dividing, power should be subtracted. A to the power of q minus r. This is a property, in algebraic property it is. So, x by y is a to the power of p, x by y is a to the power of q minus r. Therefore, a to the power of p is equal to a to the power of q minus r. When bases are same and equal, powers are also equal. Therefore, p is equal to q minus r. What is p, children? Therefore, log p means x by y to the base a is equal to log q means x to the base a minus log y to the base a. This is what the proof of this theorem, children. That is called as quotient theorem. The quotient theorem says that let a, x and y be positive real numbers where a is not equal to 1, then log x by y is equal to log x to the base a minus log y to the base a. So, LHS log x by y to the base a, we are considering it as p. So, its exponential form is a to the power of p is x by y, and log x to the base a is equal to q. Its exponential form is a to the power of q is equal to x. Log y to the base a is equal to r. Exponential form a to the power of r is equal to y. But what you are having, children, we need to find out x by y. So when I am dividing it, I have to divide a to the power of q by a to the power of r. When bases are same and dividing, power should be subtracted. This is our algebraic expression. So x by y is equal to a to the power of q minus r. Already x by 5 is a to the power of p. So a to the power of p is equal to a to the power of q minus r. Bases are same and equal. Powers are also equal. So P is equal to Q minus R. P means log x by y to the base A. Q means log x to the base A. R means log y to the base A. So this is how you could prove this rule, children. Sometimes in the exam they are asking you to prove these rules. Under 2 marks you are getting them. I hope you have followed. Now, so basing on this, you have one more. Do this exercise. This is in the same page 22. Express as difference of logarithms. This is the problem, children. The first one is 24 by 34. You can write it as this implies log 24 by 34 to the base 10 is equal to log 24 to the base 10 minus log 34 to the base 10. Why are you writing it? Because log x by y to the base A is equal to log x to the base A minus log y to the base A. Basing on this rule, you have done this. Now, the second one, 4325 divided by, you have got 373. 373 divided by 275. It means what, children? When you write log 373 by 275 to the base 10 is equal to log 373 to the base 10 minus log 273 to the base 10. The reason is same. Okay. Now, the third bit, 4325 divided by 3734. 3734. 3734. This can be written as 4325 by 3734 implies log 4325 by 3734 means log 4325 minus log 3734. The reason is same. The same reason you will be writing. Now, fourth bit, 5055 divided by 3303. You can write 5055 by 3303. So this implies log 5055 by 3033. This means log 5055 to the base 10. These are all to the base 10. Here also number means you have to write base 10 minus log 3033 to the base 10. Until and unless they give any other base, children, you have to consider it as base 10. So I hope you have understood these sums, children. Copy. Now, you have another rule, children, that is the third one is the power rule. Actually, the theorem for it is if A, X and Y are real numbers. They are real numbers. Where a is not equal to 1, and then you have got the properties log x to the power of n to the base a is equal to n log x to the base a. This property rule is not to be proved for you children for this 10th class syllabus. So you only just learn this property. Log x to the power of n to the base a is equal to n log x to the base a. This is the one. Basing on this, let us see, do these sums. Do these sums given to you, page 23 I think. So page 23 I am going to do these sums. So what are the do these sums? I will do, otherwise in a new page you just copy it. Page 23, do these sums. The question is using log x to the power of n to the base a is n log x to the base a. Expand the following. So the first one is log 7 to the power of 25 to the base 2. How will you write this, children? 25 log 7 to the base 2. The reason log x to the power of n to the base a is equal to n log x to the base a. That's all, children. Just you have to expand it. Log 8 to the power of 90, I think it is. Oh, sorry, 50 to the base 5. 8 to the power of 50 to the base 5 can be written as 50 log 8 to the power of 8 to the base 5. Same reason. Now, the third bit, log 5 to the power of 23 to the no base means take it as a 10 is equal to 23 log 5 to the base 10. The reason is this. If at all any number is given, they will give you, children. If they have not given, you can consider it as 10. Then log 1024. Nothing is given. You take to the base 10. So you can do one thing, children, here. They have not given it as a power of any number. So let us take 1024 and go for this 2 5s are, 2 1s are, 2 2s are, 2 2s are, 2 5s are, 2 6s are, 2 1s are, 2 4s are, 2 8s are, 2 6s are, 2 4s are. That means 2 3s are, 2 2s are. Of course, 32 means 2 to the power of 5. 32 means 2 to the power of 5. It is a common property which we all know. 2 to the power of 5, 1, 2, 3, 4, 5. That means it is log 2 to the power of 10 to the base. This can be written as 10 log 2 to the base 10. The reason is this. I hope you have followed, children. You copy this. Now, with this, I wanted to stop the class. Next class, I will be doing the next one. Once you copy this, children. Okay, children. Bye.